Hello, everyone. This is Belinda Kaur. Welcome back to the Movers and Breakers podcast, where we dive into the world of construction and explore the stories of people and companies who are shaping the future of our industry. From the latest innovations to the challenges and triumphs of everyday individuals, we bring you the inside scoop of what's happening in construction. Today, I'm speaking with Eric Law, founder and CEO of Urban Machine in California. Thanks for joining us, Eric.
Thank you for having me, Belinda.
I came across your company a couple of weeks ago. I think someone referred to it and sent me the link to your website. It's a pretty cool idea because I actually have a little bit of shared experience when it comes to reclaiming wood. We can touch on that a little bit later. But your new company that you've been working on for the past just a little over a year, Urban Machine, hopes to reclaim old lumber and use it for new construction. I mean, that's simplifying a very, very complex machine that you have built. But in essence, that's what y'all are trying to do. But before we dive into the specifics of the machine, I was wondering if you could share a little bit about your background and how you came to this idea and why you're so passionate about tackling construction waste.
Yeah, absolutely. So I've got my 20-year career in construction and technology. I'm a mechanical engineer out of school. I've gone between contractors, software companies, combined the two together a couple times. I built a SaaS company from 2006 to 2015 that was acquired. And then I built an innovation program for a large contractor. And it was actually there where I got involved with their sustainability initiative. And we were taking a look at waste streams coming off of our job sites. And concrete and steel both have recycle paths. They're not ending up in the landfill, which is okay. But the wood and the glasses and plastics was all heading to the landfill. And wood in particular is one of the largest contributors to landfill waste here in the United States. So it wasn't just a waste problem, it was a massive waste problem. The EPA says it's about 37 million tons of conventional lumber heads to our landfills and incinerators every year here in the U.S. And to put that in perspective, that's about half of what we log from our softwood forests.
Okay.
Right? So it's it's not a good thing.
Yeah.
And, lumber is one of the predominant building materials for our housing stock, right? You look at single family to low rise multi-tenant is all wood framed buildings. And so we saw wood prices during COVID at some dramatic highs, 4 or 5x their historical lows. And that had a huge impact on affordability. And so when I took a look at this problem, I'm like, this is a great problem for robotics. It's highly repetitive. People don't want to do it, right? Nobody wants to pull nails. Everybody we talked to, we just got back from the Mass Timber Conference, and everybody came and visited our booth and our demo, and it's like, oh man, I pulled nails. And everybody's got horror stories of when they started out in construction with pulling nails or some side project. And nobody said this was a good thing to do, hand pulling nails. It's painful, it's repetitive. Nobody likes to do it. And so that's a great opportunity for machines. And so I reached out to Andrew Gillies, who I'd done some other research on robotics with.
And that's your co-founder?
Yeah. And he said, yes, absolutely. I can build a machine to do that. And so he became my co-founder. And then he brought in Alex, who's a computer vision AI expert. And so the three of us jumped on the problem and went and raised some money. And here we are about a year and a half later, getting ready to send our first production unit out to the field.
That's pretty exciting. So y'all started in October of 2021 with this vision. Y'all had a vision, but you hadn't developed a machine yet. It was something that you have been working on. So what is the process of building this machine been like? I'm sure it hasn't been easy.
Yeah. So the first step was educating Andrew and Alex on the problem. So conceptually, they understood it. But so what I did is we went on some field trips. We went to some wood manufacturing companies. We went to waste processors to show them, here's what waste lumber looks like. We went to job sites to get them both exposure to it.
All within your local area in California. In LA? Sorry, in San Francisco.
Yeah, we're in the Bay Area. And so I took them on field trips to show them job sites, what construction wood looks like. Because they're both super sharp technical folks, but they hadn't had real exposure in the construction industry. And so in order to solve a problem, you got to get your technical folks that exposure. And we started collecting material. So we had dump trucks start bringing us loads of material. And it was cool because the demo contractors are like, how many trucks do you want? right? We'll give you guys as many truckloads as you want because they don't have to pay the tipping fees on it. So
So
we
when
got
you say
some.
tipping fee means that the fee to send it off to landfills, right?
Correct. Yep.
So y'all were getting all this material for free, basically.
Yep, exactly. And so we're analyzing different dimensions, different lengths, how it gets transported. And then we're taking that and building prototypes of end effectors and tools to start moving the different fasteners we were finding in the material. And then on the software side, we were doing a lot of scanning to build up a data set of lumber with nails, screws, and staples sticking out of it. So we could train our AI algorithms with it.
Wow. So y'all came, it was basically a step-by-step process. You had the material, then you're like, okay, what steps do we need to take to clean up this lumber? Because it's not just nails and screws. A lot of it can be rotten, can be infected with insects, and water damage, might have water damage. So only a portion of it can be reclaimed. And then even cleaning the top and bottom surface of the wood as well. There are surface irregularities. So it's not just a simple step of pulling out nails and screws. There's a lot to it.
There it is. There is. And we keep our scope focused on metal free. Our goal is to get the wood metal free. Because what we learned is the reason why this wood's not being reclaimed is the metal, and that metal can't go through traditional wood processing lines, right? You can't run a planer over a nail because that nail will destroy the planer
Yep.
blade. And so as we met with all these different folks in the industry and chatted with them about the problem, and we met with existing salvage folks who were hand pulling these fasteners, everybody said your goal has to be metal free wood, right? In order for this to scale, you got to get it metal free. And so with that is kind of our goal from the industry to say, hey, we'll buy this material, but you got to guarantee it. That's what we have to do. And so we have an 80-foot long process line now with the goal of metal free wood, where it comes in one end full of metal and it comes out the other end without any metal.
I see. So you're tackling a particular portion of it. You're not trying to create a new type of dimensional number, all standardized, and then sell that. It's just creating metal-free wood, selling it off to other customers, and let them do whatever they want with that lumber.
Exactly.
That's an interesting approach, and I'll tell you why. At the beginning of our conversation, I said that I have some personal experience with this. So in 2015, my husband and we started this company called Pallet Snobs. Because everyone, pallet wood furniture, pallet wood art was all the rage in 2015 and 2016. And we were living near an industrial area, and we saw tons of pallets discarded all around the roadside. So we joined a woodworking space called Dallas Maker Space. And then after our 8 to 5 jobs, at 5 o'clock, we would go and pick up all these pallets, put them in the back of my husband's truck, take them to the Dallas Maker Space and pry them apart, and then pull out the nails one at a time, clean them up on a planer, cut them down on wherever table saws. But then we took it a step further, where we would glue these pieces together or join them together and create artwork and furniture. So yeah, and then we would sell it to family members and then sell it online as well. But it was I would say negative ROI because of the amount of effort that went into it, which is why I appreciate you identifying a certain portion of the entire chain. You're not trying to tackle all of it. You're saying it has to stop at a certain point. Otherwise, the labor involved in transforming reclaimed lumber to completely finished lumber is just too extensive. It's not logical. It's not profitable to do everything by yourself.
Exactly. And there's a lot of existing companies in the space, right? So there's all these wood manufacturers that take virgin lumber that is close to metal free. It's interesting. There's actually a lot of metal that comes out of the forest, we learned when we were visiting sawmills and wood manufacturers, because as those trees grow, people go hunting. So bullets end up in the trees. People put up signs, people put up wires and fencing over, 50 to 100 years of a forest. And so when they cut down the trees on virgin mills, they have to run metal detectors to go look for that material because they can damage a virgin mill with that material.
I didn't know that. Oh, wow. So you're saying that those companies already have some metal extraction facility capabilities in the factory?
Yeah, it's mostly just detection. And then if they detect it, they just slice it out because it's usually buried in the middle of a log. So if they do detect metal on a log, they kick it off to the side and send it somewhere else.
Ah, okay. So what have you all currently accomplished with the wood that you have reclaimed? Have you all used this reclaim lumber towards building projects, or has it mainly been more like hobbyists who use this lumber?
Yeah, so we've got a couple customers that are using it in commercial applications. One of them is using it for architectural products. So think like ceiling grids, wall panels, architectural facades. We have another customer that bought some material off of us and has created some flooring out of it. Some older Douglas fir beams, they ripped it into flooring planks. And then we have another customer that's creating small batches, kind of test projects with furniture. So they're testing like conference tables and planter boxes and corporate furniture for offices. And all of this is kind of small runs. Everybody's kind of playing with it, testing it because we're not at volume yet. But as our engineers clean wood and test the machine, we end up with clean material. And so then we sell that to these folks for test batches. It's going really well. Everybody loves the product. They love the story. The other thing that's cool too is, we track the building where this material came from, if we know that. And so we could tell a story to go with it that says, hey, here's a batch of material that came from this old warehouse in South San Francisco type of thing.
People fall for that. That's a good idea. That's a good selling point. And even if it's just for interior siding, like you said, if there's a plaque or something with that, it becomes a feature, a real feature wall within a commercial space, or I don't know, maybe in a residential space. There is the story that goes along with it that you can convey to people walking through. That's an interesting strategy. Very nice.
And we're going to do it with printed QR codes. So we're going to put QR codes on all the wood we processed, and it'll apply to a one page, and I'll show the history of the material. So, imagine walking into the lobby of an apartment building, and there's a QR code on a wood column, and you hit it up and says, hey, the wood from this building came from another project down the street that used to be, an old cannery or some type of processing facility.
Whenever you tell the story, I mean, it has so much potential, but the one concern that comes to my mind is like scalability. Being able to guarantee large volumes of standard materials, because even if it's just siding or just flooring, the person who wants the finished material wants some sort of cohesiveness in the product. How do you guarantee that?
Yeah, so what we've done is we've broken the material that we process into two categories. We have that older growth premium material, larger dimension, larger cross sections. That when you plane it or cut it, you get that beautiful historic look, right? And so that's kind of our, 60-year-old and older material is typically in that category. And that's where it goes for architectural presentation. And then we have the other side of the house, which is kind of that newer 0 to 50, 60-year-old type material. That's still, solid wood, good lumber, good structural integrity, but it doesn't have that same tight grain pattern. It's, second or third generation. And so that we're actually working with some engineered lumber manufacturers to demonstrate, taking all these 2x4s and 2x6s and fastening them together to create large elements that can be reused to build an entire building. Imagine using like cross-laminated timber that's made from reclaimed lumber. And so we're going to be doing some testing with that this summer.
So mass timber equivalents to, oh, wow. But are there structural concerns when it comes to something like that? Because those materials have to be tested, right?
They do. So they've got to be graded. And one of the things about cross-laminated timber is the concept is to actually use lower grade material, smaller trees from the forest to build these panels, but then you use lots of it. And you use it in multiple orientations to create strength. The great thing about our material is it's typically, older material, so it's higher strength and higher quality than what you get today out of the forest. But we can use the same processes and technologies they use in a mill. It's all visual graded to give it a visual grading. Or we've got an X-ray machine in our process line that we can look inside and look at the grain patterns and look for knots and cracks to give it a grade as well. So we're in the process of writing the software that'll do that grading. So if a client wants graded wood, we can process that with our machine and provide it to them.
So even though the products that come at the end of your assembly line can be varied, you can still assure some sort of structural standards to them?
Absolutely. Yep.
Oh, that's interesting. Can you walk us through the assembly line of the machine that you've created, the software and the hardware side of it?
Yeah. So on the hardware side, we'll start with an in-feed. So typically our machines are portable. So they'll show up on a demolition site or a waste processing facility and we'll operate there. And we want to park next to a big pile of wood. And when I mean big piles, these facilities have piles that are, 40, 60 feet tall, 100 feet long. It's massive amounts of wood that come out of these buildings and that are in these facilities. And so we start feeding it from forklifts or skid steers on the job site. And initially we have a human interaction in feed station because sometimes there's like an electrical box or a structural fastener on this piece of material. And so we got to take that off. And so that's what the humans are good at because it's a lot of different fasteners, a lot of different shapes and sizes. And then once those components are removed, they push it into the machine and then the automated process takes over. And so then we have brushes that remove surface contaminants from it. Then it goes into pickers that start pulling the nails off of it and the staples off of it. Then we have another cell that does the screws that starts removing the screws, show if there's screws on it. The x-ray is in line as well before it gets to the pickers and the screw extractor. And then the last step is a metal detector. So we're using a good old piece of technology to make sure we got all the metal out. And if it comes out, we print a label on it and then off it goes. If it fails, then we put a dot where we think the metal is, and we send it back around and try again.
That's absolutely fascinating. You have a very, very cool video on your website. I mean, you've described it really well, but I'd encourage people to go see it because seeing the arms come out from the sides of the machines to pick out all these nails and screws, it's pretty cool. It's a very complex task that you all have been able to convert into code and successfully turn it into you've managed to turn an idea into reality. And it's very impressive. I have a question about one of the claims that you've made on your website and on your LinkedIn page. You say that Urban Machine is on a mission to convert 37 million tons of wood waste from construction and demolition into $18 billion a year worth of high volume, locally sourced premium lumber. How did you get to that $18 billion number?
So what we did is we took a look at that 37 million tons, and we know we can't get 100% of it, right? And so our target is to capture 50% of it. And then we looked at the different cross sections of the material, the different sales price of the material, because you've got, on the low side, you've got virgin lumber 2x4s. And right now they're back at the bottom, and I think it's about 35 cents a board foot mill price today. And then you've got the old growth premium 4x12s, that stuff sells for $6 to $10 a board foot, right? Wholesale. So you've got this huge range of prices. And so we took some Excel spreadsheets and we started looking at the volumes of the different materials. And we figured, if we cover about 18 billion board feet with an average sales price of $1 a board foot, it's an $18 billion market here in the United States. Is how we got to that.
Okay, I see. Before, when we were talking about your machine being portable and going to the job site, I was thinking about the way the way our industry demolishes buildings, and they're pretty destructive. They don't actually take apart buildings piece by piece, which is unfortunate. But maybe y'all can come in and change the mindset and tell people that they don't have to just cut down lumber into small little pieces when they're tearing a building down. It is more expensive. It is more labor intensive too, but if they could be more intentional with the way they remove elements, that would increase the input that can go into your machine.
Yeah, absolutely. Which actually saves the contractors money because then they don't have to pay to throw it away. One of the things when we were talking about the demo contractors is they're like, we'd love to recycle wood. We hate throwing it away. It costs us money. And they're like, our whole business model is made on smashing it up into as small pieces as possible to minimize the number of trucks, right? So their whole economic incentive is to reduce trucks. And so they shred it, they smash it, especially on the residential side. Everybody sees the excavator run over the house, right? And turn it into toothpicks, we call it. So now that we're going to change those economics, suddenly we're going to create a demand for that material so you no longer have to go throw it away at a landfill. And so that can drive the change where the demo contractors are like, some buildings, it's the same price for us to deconstruct as it is to smash it up. If you think of like a big old 1950s warehouse with big roof wood trusses, because it's all exposed in those warehouses, it's very easy for them to pull that apart and essentially harvest that building instead of smash it up. When you get down to single family residential, it's a little harder because your 2x4 walls are small dimensions wedged in between two layers of sheetrock. But there's a bunch of government ordinances coming out that are requiring deconstruction because one of the big drivers there is the landfills are filling up. And so all these municipalities don't want to go build a new landfill, right? It's billions of dollars, it's decades, all the permitting, environmental laws across the country are going to make it really hard. And so what we're seeing is cities like Portland, Oregon and San Antonio, Texas are requiring deconstruction for these old buildings and saying, no, don't throw this material away, reclaim the wood, reclaim the metal, take everything out of it and let's reuse those materials. Because not just the wood is good, there's a lot of other great valuable materials in these buildings that can be reused.
So how do you tackle a regional waste? Right now, y'all go to demolition sites around San Francisco, and you'll take your robot or the machine that you've built to this demolition site. But what's the plan to expand and move to other states or even around California too?
Yep. Yeah. So this year, our goal was to build 2 systems. So the first one will come out here in a couple of months. We'll start running around and then have a second one by the end of the year. Those will be based here in Northern California, Greater San Francisco Bay Area. And then next year, our goal is to build 12 systems and deploy those to 6 different markets. And what we want to do with that is we want to go test those different markets. Because the reclaimed lumber market in the Pacific Northwest, where there's lots of wood manufacturing, lots of virgin, is different than it's going to be down in, say, Texas. Because Texas doesn't have any trees, right? So Texas imports all of its wood, but it still builds a lot of buildings with wood. It just has a very long train ride out of Canada, the Pacific Northwest, or out of the Southeast to get to Texas. And so what we want to do is we want to go prove our technology and the market can be developed in these different environments, right? And those are kind of our 2 extreme examples, right? Up in the Pacific Northwest with all the trees, down in Texas without the trees, to show we can source the material from the demo contractors, we can supply it into wood manufacturers that will consume enough volume to support our business case.
But when you talk about those 2 areas, the type of wood that you get from those kind of projects is also going to vary significantly. Like here in Texas, you're probably going to have, you talked about dividing the lumber from 50 years and older to 0 to 50 years. You're probably going to have much newer wood and 2x4s and new growth lumber, not so much of old growth lumber here in Texas, as opposed to in the Pacific Northwest, where you might have a lot of more older homes that are being demolished, or not just homes, but buildings too, commercial buildings.
You've still got the older parts of Texas that it was built with wood. They've been building with a long time down there. But you're right, the larger volumes will be younger buildings that are coming down. And what we're seeing is it's the major metropolitan areas, because most of the metro areas are demolishing their 1 to 4 story buildings to put in, 10 to 20 story buildings, right? Everybody's increasing density. If you look at like Austin, Texas, or Seattle, or Portland, they're all taking down these old commercial industrial buildings or multi-tenant apartment buildings. And those have a lot of wood in them because they built with wood before steel and concrete became predominant players in those structures. It was all wood across the country. Then when we head in the Northeast, we're going to see a lot of different species. I mean, they've got wood that's 200 years old, some of the buildings up there when you head up in the Northeast. But they built with like oak, and they built with spruce, and they built with all these different types of material. Some are hardwoods, some are softwoods. And so that'll be fun when we start to get to go up there and process those materials, because it'll be very critical to us to sort those out. Yes. Right? Because companies that reuse oak are different than companies that reuse spruce or larch or any of those different species of trees.
Are you concerned about the amount of warehouse space that might be needed for your company? Because when you all do process this, you still have to, like you said, sort them out and the type of materials, the age of the material, maybe the grain, the dimensions of these materials, and then find the right customer for that particular product. It's different. It's a different approach as opposed to a company that comes to you and says, I want this exact type of wood, these dimensions, and then you magically go find the project somewhere in the States that's being demolished that has that exact type of wood.
Yep. Yeah, so we're doing a couple things. Our goal is to actually try and get to a point where we can predict wood that's going to come out of a building before the demo contractor takes it down. So we'll get some insight into it. So as we process this material and as we learn about the source and where it came from and what came out of it, the yield and all that, Our goal is to use that data set to then be able to predict wood coming out of buildings. And then the other aspect is there's a lot of existing storage capacity in the current lumber industry. Most lumber yards have big real estate. Most wholesalers have real estate because they hold the virgin material or they truck it through and stuff like that. And so we're going to try and plug in with those folks to the point where I don't need to set up storage capacity. I know as we're processing the material at these job sites, as soon as we have a truckload of dug for 2x4s, I know that can go to customer A. If it's dug for 4x16s, that goes to customer B. And then they will process it and turn it into products. And so our goal is to work with those partners that have that storage capacity to handle that instead of us having to build another set of warehouses and double handle the material.
Okay, that's an interesting strategy. What has the reception from the industry been like? Like when I'm sure it's a novel idea when you come to people and then explain what you do. They'll be like, "Wait, what are you doing? I expect to send all this old wood, demoed wood to the wood chipper." But like you say, when they understand the financial aspects of it, where they don't have to pay to dump this into a landfill, that's probably a big incentive for them. But up to that point, is there a lot of education involved in teaching people about this new technology?
So since we're going to be operating in the technology, we don't have to train them. Most people see it right away and they're like, "Oh, that's awesome. We really need,"
Okay.
right? I mean, it's a huge pain point, and there isn't really. It's not like we're replacing a labor force. A lot of other robotic solutions are like, "Hey, let's go replace the 100,000 people doing this." There aren't 100,000 people pulling nails today, right? Most people, it goes in the bin. There is a niche industry that does it for like barn wood. They're really premium products out there, but they're, probably single digit, low 1 or 2% of lumber gets reclaimed here in the country. It's a pretty small business. And so we want to scale it and solve a problem that isn't solved by humans today because it's just so laborious and so tedious. And so everybody, when we're at the conference up in Portland, everybody's looking at our machine, they're taking videos, their pictures, they're like, "Hey, you got to talk to this person. We want to chat with you. We want to do this. How do we get one?" Everybody keeps asking us, "How do I order these? How do I place?" I'm like, "Hang on, we got to wait a couple of years. This stuff takes a while to build."
Yeah.
And so seeing that energy and interest in it's phenomenal, right? Seeing an idea go from a drawing board to prototypes to a conference where people are jumping all over it and excited about it. It's great to see. And it's also a problem we have to solve.
Yeah.
There's nobody that says we got to keep throwing wood in the ground. I don't care about politics, construction. Everybody's like, "No, we can't keep throwing this beautiful material away. It's got to get reused. It's got too much value to go in the ground."
Yes, that's a tricky thing for your company, because when you start selling the machine, then there's a conflict about what is the company? How many things are we going to tackle? Are we going to be the people that sell the machines and fix them up and address customer issues when things break down? Are we going to be that kind of company, or are we going to be actually tackling the construction waste, cleaning up wood and selling wood? That kind of splits your company when you start going down that venue.
So we're going to be doing both.
Okay.
So initially, because in the supply chain today, the waste folks are not connected to the lumber folks, right? The waste folks go to landfills, they go to incinerators on the demo side. The lumber industry goes to the mills. And so we need to create that connection. So we're going to be selling wood for a while to build that relationship and the link in the supply chain. And then as we establish that and we demonstrate the value and the proof of it, and here's how it works, we're also refining our technology. It's one thing to build these machines, but it's another thing to make them, Staples easy button, where they hit a button, they turn it on, and they just feed wood into it all day long. And so we want to get our technology to that point. And so that's going to take some time. And so during that process, we'll operate the machines, we'll iterate on them, we'll make them more stable, more reliable. And then as we scale, we'll demonstrate the benefits. And then at some point, customers are going to be like, "Hey, I want to buy this. I want to rent this." And we'll be like, "Yep, we're confident in our technology." We'll put them in the rental fleets and we'll scale it because it's going to take about 6,000 of these systems just here in the United States.
Wow. Okay. Um, is modularity an important part of the design of the machine? Because whenever I talk to people who have similar ideas that you do and have built similar machines, they always talk about building the system as a series of modules. So if one particular part, say the part that pulls the nails out, if you've come out with a new version of it, an improved version of it, you can replace that particular part of the machine without having to redesign the entire thing.
Absolutely. You're spot on. It's not just an iteration, but if one module breaks, you can swap
Yeah.
them out. It's for reliability, future proofing it, and everything in our system is modular. And so think about it, you got these big trailers and we install all the modules on it. All the modules plug in and talk to each other through the network. And then if one of those needs an upgrade, if one of those needs, to be refitted with new tooling, you can just swap that module out and drop another one in.
Very cool. So thank you for sharing the story behind Open Machine. And I really appreciate how you've identified a single problem and created a machine to tackle that problem. But to end our discussion, do you have any advice for people who want to change mindsets in an industry that is so resistant to change?
Yeah, absolutely. Yeah, construction is a tough industry to change. I've been trying to do that for 20 years of my career. It's an uphill road. Um, the key thing is when you find a problem, you need a big problem, right? Lots of people involved, not necessarily involved with it, but a big scalable problem. So the ROI pencils out on making large investments. The other thing you want to do is how do you change the industry without changing the workflows? So one of the things we looked at is when we were designing our process, and how far left and right we want to go, is I don't want to make dramatic changes to my industry participants. So that's my waste stream on the left, and that's my wood manufacturers on the right. And so how do I integrate into their workflows and not have a dramatic impact on it? And so that's where we talk to the demo contractors. We're like, okay, here's our ideas. Here's what we want to do. How do we tie in with your existing workflows? And then with the lumber industry on the other side. Because if you can bring change to an industry and it doesn't feel like a major change or an impact to the users, there's always some small changes. That's where you'll start to get the bigger wins. And you'll start to get a lot more traction faster. If you go to a contractor and say, hey, look, you have to deconstruct every building and you got to do it this way and you have to deliver it to me this way, you're going to get so much resistance.
You could be out the door.
Exactly. We go to them and we're like, give us a pile of wood. Just give us a great big pile of wood next to your pile of concrete, next to your pile of steel, just like you do with steel and concrete, and we will process it. And they're like, yeah, we can do that. They're like, that's not a problem. We know how to do piles. And away you go.
That's pretty good advice. So thank you, Eric, once again for sharing all that with us. I really appreciate it and hope to meet you in person soon.
Excellent. Thank you very much for having me, Belinda. This has been awesome.